Hi, I'm Mike Stanzik with Digital Electronics Classroom, and I want to welcome you to this video. This video today is just going to be a short video where we're going to look at combining the power equation with Ohm's law expression. So let's get started. So if we combine power with Ohm's law, we're looking at the power expression as voltage times current, and we're looking at the Ohm's law expression where current is V over R. Okay. So we're looking at calculating that power, and let's go ahead and take a look at a situation. So if I have a circuit element, and I don't necessarily know what it is, but I told you that the voltage across here was 5 volts, and the current through here was, and it goes from plus to minus here, so we can see that this is, in the associated variables convention, that this is going to be a receiver, so it's going to receive power, so it's going to be a positive power. Alright, so let's say this was, say 20 milliamps. And so what is the resistance, or what is the power delivered here? So P is just V times I, and so that's going to be equal to 5 volts multiplied by 20 milliamps, giving us 100 milliwatts, and or 0.1 watt. Okay, so that's using power equation just how we expect it to be used. But what if we had a situation that looked like this, and we have a resistor, and this resistor is 10 ohms, and I said that the voltage across here was, say, 7 volts. Okay, can I figure out the power delivered to this resistor? Power is equal to what here? And the answer is yes, we can, because we can make a substitution with the power equation and the Ohm's law equation. So I want to end up with V and R. I don't know I, so I want to substitute in for I. So if P equals V times I and I equals V over R, then substituting this I in here, we have P is V times V over R, which is V squared over R. And so this is another way to write the power expression. P is V squared over R, and it doesn't have I in it, so I don't need to know the current, I just need to know the voltage and the resistance. And so substituting in here then, I get 7 squared over 10, which is 49 over 10, which is 4.9 watts. So that's pretty cool. I can do that without knowing what the current is. And then in our last situation, let's do resistor is 25 ohms, and this time we have a current, and say that current is let's see, 0.4 amps. Okay, and so what are we gonna get here for the power? Well, in this case, I know resistance, I know current, and I'm looking at my two power equations, and neither of them will give me what I want. So I'm going to rearrange the Ohm's law equation to say that V is I times R. Okay, and then if I say that P is V times I, and I know that V is I times R, I can substitute this V in for the power into the power equation, and I get P is I times R times I, which is equal to I squared times R. And so then I can just plug in. So we got I is 0.4 squared, and times the R, which is 25. And so what we get here is 0.4 squared is 0.16 times that 25 is going to give us, what is that, 4? 25, 1.6 divided by 4.4 equals, is that right? 2.5, 1.6 times 2.5, 0.25, 16 times 0.25, no, it's going to be 4. So this gives us 4 watts. Sorry about that, I had to do a little math in my head. Okay, so that's how we can get rid of the voltage term. And so in this case, we can solve for the power knowing just the resistance and the current. And so we get this expression, P is I squared times R. So we have 3 expressions for power, and whether we know voltage and current, whether we know voltage and resistance, or we know current and resistance, we can relate that to the power and calculate that power. Okay, that's all there is to it. Thanks again for joining us today. My name is Mike Stanzik. This is Digital Electronics Classroom. I want to encourage you to subscribe to the channel, and as always, have a wonderful day.